The Pythagorean theorem, the most famous proposition about a right-angled triangle.
Who was the first concerned with right-angled triangles?
A long time ago in Egypt, they knew right-angled triangles and used them for the construction of pyramids. The Egyptians would tie 13 knots into the rope and create 12 equal parts between them. They'd join the beginning and the end of the rope in order to form a triangle with side lengths of 3, 4, or 5 parts. The Egyptians knew that the right angle is formed that way. Later in ancient Greece, people asked, how can a triangle with sides 3, 4, and 5 have a right angle, and a triangle with sides 4, 5, and 6 not be right-angled? Greeks not only asked the question, but they also found the answer.
How can we recognize the right-angled triangle?
In any right-angled triangle, the area of the square, whose side is equal to the longest side of the triangle, is equal to the sum of the areas of the squares, whose sides are the 2 shorter sides of the triangle.
And this is the Pythagorean theorem.
The Pythagorean theorem is named after the famous Greek mathematician and philosopher, Pythagoras. Pythagoras of Samos lived approximately between 580 and 500 BC. When he settled in Croton, in southern Apennine Peninsula, people used to say about him, there are people, there are gods, and there are beings like Pythagoras. Pythagoreans were obsessed with numbers. They tried to capture the world's harmony with number relationships. Pythagoreans concealed their teachings so well that today we do not know exactly what was the work of Pythagoras and what was that of his disciples. And this is also true for the famous Pythagorean theorem. The Greeks are now considered to be the founders of mathematics. Civilizations before them dealt with the question of how to calculate something, but the Greeks began to ask questions and find answers to questions of why it can be calculated that way.
Why is the Pythagorean theorem true?
Today we can find several hundreds of different proofs of the Pythagorean theorem. Let's look at one of them. It may be surprising, but we can replace the squares in the Pythagorean theorem with other shapes, triangles, hexagon, and semicircles, provided that they are similar. The sum of the areas of these figures for the legs will again be equal to the area of the figure for the hypotenuse.
And what is the importance of the Pythagorean theorem today?
Discoveries of ancient peoples in physics are now viewed as out of date, but in mathematics it is different. Thanks to the ancient Greeks and their proofs, mathematics is the only scientific discipline where what was true 1,000 years ago is still valid today. The Pythagorean theorem plays an increasingly important role in many branches of mathematics. It is the foundation of trigonometry, and in the arithmetic form combines geometry with algebra. The Pythagorean tree, created by modern fractal geometry, is a beautiful connection of modern mathematics with the classical Pythagorean theorem.